A localized thermal event in an office setting accelerates exponentially. Within moments, nearby ordinary combustibles reach their ignition point. When a fire starts, you have exactly 30 seconds to act before it becomes a catastrophe. Do you reach for the red bottle? Which one? If you choose wrong, you could turn a small flame into a massive explosion. This is the ultimate guide to fire extinguishers. Effective fire suppression requires more than simply dousing a hot surface with liquid. It is a targeted intervention designed to interrupt specific molecular processes. Deploying the incorrect chemical agent onto a specific fuel source will fail to put out the fire, and in many cases, it violently amplifies the hazard. Combustion is not a physical entity. It is a continuous, self-sustaining chemical chain reaction. This geometric model illustrates the 4 absolute requirements for that reaction to exist: the fire tetrahedron. Fuel, heat, and oxygen must be present simultaneously and in the correct proportions to trigger and maintain the 4th element, the uninhibited chemical chain reaction. To kill a fire, you must remove a side. Each extinguisher provides a surgical strike against the physics of combustion. Every compliance rule, maintenance check, and OSHA mandate exists specifically to guarantee that these precise chemical tools deploy flawlessly when a worker faces an ignition event. Safety professionals rely on the 5 United States standard fire classifications to map specific fuels to the correct chemical weapon. This chart details the appropriate suppression agents for distinct fire types. Looking at the columns for Class A ordinary combustibles and Class B flammable liquids, we see a divergence. Class B fires require an agent capable of smothering explosive vapors, rendering cooling methods ineffective. Applying pressurized water to a Class B grease or oil fire instantly vaporizes the liquid, expanding the fuel footprint and throwing burning oil across the room. Moving across this chart to Class C hazards, which involve energized electrical equipment, the required chemical must be entirely non-conductive. A water-based agent here would act as a live wire, carrying lethal electrical current directly back to the operator. Class D hazards involve combustible metals like magnesium or titanium. These extreme temperature fires require a specialized dry powder designed to absorb intense heat and permanently exclude oxygen. Finally, Class K fires involve commercial kitchen greases. These require wet chemicals that induce saponification. Saponification occurs when the alkaline agent reacts with fatty acids in hot oil, instantly creating a soapy, cooling foam barrier that seals off oxygen. Mastering these chemical relationships prevents catastrophic operator mismatch and ensures the auditor correctly identifies the physical risks in a given environment. An ABC dry chemical unit houses specialized powder beneath compressed nitrogen gas. When the valve opens, the compressed gas exerts downward force, driving the heavy chemical agent up through the siphon tube and out the discharge nozzle. Because this system operates under constant strain, the external pressure gauge serves as the primary indicator of internal mechanical health. The pressure gauge is your lifeline. If the needle isn't in the green, the bottle is a paperweight. There is a notable technical exception. Carbon dioxide extinguishers house liquid under such extreme pressure that a gauge would be unreliable. Their readiness is verified strictly by weighing the cylinder. Trapping reactive chemicals under constant pressure causes internal seals to degrade over time. This physical reality drives the strict, federally mandated inspection timelines. OSHA Standard 1910.157 establishes a complex, overlapping chronological matrix for equipment maintenance. The baseline is a 30-day visual inspection. Safety officers verify the physical location, ensure the tamper seal is intact, and check the pressure gauge. Once a year, the standard escalates to annual maintenance, requiring a certified technician to inspect the mechanical parts and officially log the date of service. Because these cylinders are high-pressure vessels, they must be periodically emptied and pressure tested with fluid to verify structural strength. Stored pressure dry chemical units operate on a long cycle, requiring a hydrostatic test every 12 years and an internal teardown every 6 years. In contrast, carbon dioxide, water, and wet chemical extinguishers demand hydrostatic testing every 5 years. A compliant safety audit requires tracking these staggered chemical and mechanical lifespans across hundreds of discrete units throughout a facility. Perfect chemical selection and rigorous maintenance hold zero value if an employee cannot reach the equipment before the 30-second incipient window closes. OSHA mandates Class A extinguishers be within a 75-foot travel radius of any employee, shrinking to 50 feet for volatile Class B liquid hazards. Mounting heights are also strict. Units under 40 pounds max out at 5 feet high, and heavier units at 3.5 feet. This image demonstrates compliant physical implementation. The equipment is highly visible, securely mounted at the correct height, and completely free of corridor obstructions. If a fire grows larger than a wastebasket, or if the flames block a designated escape route, the incipient stage has ended. The protocol shifts instantly from fight to flee. Strategic placement guarantees that the tools required to manipulate the physics of combustion are within arm's reach the moment a worker makes the dangerous decision to fight. When an individual commits to fighting an active fire, human panic is introduced as an unpredictable variable. Overcoming this requires a standardized tactical sequence. The protocol is summarized by the acronym PASS. First, pull the pin to break the tamper seal and unlock the operating lever. Second, aim at the base of the fire. You must target the fuel source reacting with the oxygen, not the visible flames burning above it. Third, squeeze the handle using an even, controlled pressure to discharge the compressed agent. Finally, sweep side to side. Cover the entire fuel source with the extinguishing agent to smother the reaction and prevent reignition. PASS is a tactical protocol designed to bypass panic and apply the chemical agent as efficiently as possible. A portable fire extinguisher is a temporary bridge. It is a first line of defense intended strictly to suppress a hazard until professional responders take control. When was the last time you checked the pressure gauge on the extinguisher in your kitchen? Tell us in the comments. If you want to learn more about workplace safety and OSHA rules, subscribe to HSE Study. Maintaining rigorous audits, understanding chemical suppression, and adhering to mandated maintenance schedules are the ultimate defenses against the physics of fire. Stay safe, and we will see you in the next video.